Mass and weight section. True or false? The amount of matter in an object is called the weight. Amount of matter is actually called the mass. So I'm going to say that this is false. True or false? The unit of weight is kilogram. The unit of weight is actually Newton. Remember, weight is a force of gravity, the force of the earth pulling on you, and every force is a Newton. True or false? The sum of all forces that act on an object is called the net force. Well, that is this equation right here. The net force is the mass times acceleration, also known as the sum of all forces. That's what this fancy E means. Sum of all. Add them all up. I would say this is exactly true. Put it on a flashcard. Memorize it. Very true. After a cannonball is fired into a frictionless space, the amount of net force needed to keep moving equals what? Now, when I read a question like this, I don't even read the answers yet. I think of what is my best answer and which of the options best fits my best answer. So, cannonball. So, I'm thinking of a ball flying in space. Now, this part is kind of extra information. It's not super needed. What I need to know, the cannonball is moving and there's nothing acting on it. There's no friction, there's no push or pull, there's no gravity on it, there's no normal forces, there's no nothing. If I were to draw a diagram, it would be a whole lot of nothing. It would just be a ball. So what is the force? I'm not even going to think about the word net yet because that throws some people off. That's vocabulary. But what force is needed to keep it moving? Well, if there's currently no forces acting on it, nothing, right? There needs to be no forces acting on it. Now, if I think about the actual question, net force, what that means is the sum of the forces need to end up being zero. So if I had two friends, one's pulling, one's pushing with the same amount of force, that'd be net force. But again, that's a little less direct than what I want you to get at. I want you to realize that there's no force needed. None. None soever. Zero. No force is necessary to keep it moving. That would be my answer. Which has more mass, a kilogram of feathers or a kilogram of iron? Well, we need to be very careful. Are they talking about mass or weight? They're talking about mass. Now remember what we set up here. The amount of matter in an object is called its, well, this is wrong, right? It's actually the mass. So, I was looking at the wrong question. Excuse me. A kilogram is a measure of mass. So these are directly talking about its mass. So 1 kilogram of something versus another kilogram of something else, they're both 1 kilogram. The masses are equal. Now let's imagine this question was a little different. If it was weight, no, actually it'd be the same, excuse me, because the equation is the same. 1 kilogram times gravity is going to be the same for both. Okay, so I guess it doesn't matter if it's mass or not. On the surface of Jupiter, the acceleration due to gravity is about 3 times that on Earth. About how much would a 100 kilogram rock weigh on Jupiter? So here we're dealing with some numbers and equations. So let's go back up to my equations. I'm dealing with this right here. So I need to find the weight. The weight is equal to mass times gravity. So let me write that. The weight is equal to mass times gravity And what do they tell me? They tell me the 100. Now the units are going to tell me what they give me. Is that 100 a mass or is that 100 a weight? Well, the kilograms is mass. So I know that mass equals 100. And then they tell me something about gravity, but they don't tell me exactly what gravity is. I need to remember the gravity on Earth is about 10. So they then tell me, so this needs to be in my mind. This needs to be something I memorize that they don't tell me. It's a good practice to write this at the top of your paper or on your scrap paper as you're taking the test, because we expect you to know that. And it's going to be 3 times that on Earth. So it's going to be more. It's going to be 3 times more. So 10 times 3 is 30. And now I have enough to say, well, the weight is going to be the weight equals 100 times 30 equals 3,000. And the unit for weight is always Newton. That is my final answer. List 3 differences between mass and weight. Okay, so obviously our answers may differ. I'll come up with the first 2 that I can think of. Mass is kilograms. Weight is Newton. We could say that mass is the amount of matter, I'll say stuff, in an object. Weight is the force of gravity. I will say in space, mass affects you. Weight is almost 0. We'll say that, well, similar to this, I think most people would have said, I'll make that like a sub-point. Weight changes based on what planet you go to. Similar to that, if you're in space, it's 0. If you're not near a planet, it's virtually 0. And one that you may not have thought about was inertia. Remember that inertia, we'll go over this later, is the tendency to keep doing what it's doing. And it is equal to the mass. The more mass, the more inertia. So similar to the other one, similar to C, inertia is mass. So inertia doesn't change depending on where you go. And I wonder if you can come up with different things than me, but these are some of the main ones.